All right, so in this mastery problems and solution section, we've got 4 problems, 3 ANOVA problems, and 1 test of 2 variances. So this is the first of the 3 ANOVA problems. I think I'm going to work it by hand, and then we'll work the other 2 by calculator. You'll see that it's just so simple to calculate things with the calculator. There's hardly any learning going on. So let's take on this problem. We'll knock it off by hand real quickly. This is about a test to try a couple of different treatments for high blood pressure, medication, exercise, and diet. And there's the data. Notice that we've got the same, so we've got 3 groups and the same size groups, so we can use our kind of simple formulas in order to run the ANOVA test. So let's go ahead and do that. I've got to calculate, remember, 2 different variances, the variance between and the variance within. And for this case, when all the groups are the same size, this is the size of the groups, 5, times what we would call the variance of the mean. So you've got 3 means running across there. We've got to calculate a variance for those 2. And this is just the average of all of the within group variances. So in this case, that's going to be S1 squared plus S2 squared plus S3 squared divided by 3. So I've got to do that calculation. And actually, I'm going to use the calculator in order to do that. I've already loaded into list 1 the three means, and I've loaded into list 2 the 3 variances. So I can just turn this on. Let me go verify that that's exactly what I did. So I'm looking at edit right now, and sure enough, that's where they are. So all I have to do is go to calculate one variable stats. I'm going to tell it I'm in list 1, and that will produce for me any number of numbers. The first one is S sub x bar, the standard deviation of those means, and that number is 4.001, and I believe if you square that, you get, I think it's 16.013, if I'm not mistaken. I could get the calculator out, but no need. All right, so there's the number, there's part of the number we need. I got to multiply that by 5. I'll do that down here. Let me calculate this number now. Again, I have the 3 means in list 2, so all I have to do is go back to calculate on stats, calculate one variable stats, tell them I'm in list 2, and when I run that, it will give me the mean of those numbers, and that mean is 8.733. And if you look at those 3 numbers, you get some 10s, you got some 5s. I believe that's right. So the F statistic that we're looking for is S squared between SW, at the variance within, and that is going to be 5, there's the 5, times 16.013, all divided by 8.733, and we're getting very close to finishing this problem. I'm going to switch out calculators here, the one that I can actually use. 5, 16.013 times, and now I'm going to divide that by 8.733, and I'm going to get 9.168. Now what do I do with that? That's the test statistic. I've got 2 choices. I can go find a critical value to compare that to, which is not so easy actually, necessarily. Well, it's not that difficult because we have an FCDF. If I go to second distribution and crawl down to, I think it's item number 10. There's item number 10. I could go calculate the critical value for alpha equals 0.05, but instead I'm going to calculate the p-value. So I'm going to put in lower 9.168, upper 1e to the 99th, a zillion. The degree of freedoms for the numerator is k minus 1. K is 3, k minus 1 is 2. The degree of freedom for the denominator is n minus k, where n is all of the, while this little n is the size of the groups, n minus k is all of the observations. 3 times 5, 15, minus k is 3 or 12. So I put in 12, and if I come down here, tell it to paste, and then tell it to run, I get p is equal to 0.0038, which you recognize is less than alpha, which is 0.05, and in that case, if the p is small, you've got to reject the null. And reject the null is equivalent to saying that at least one mean is different. And that's the problem. Let's come back and finish the other two using the calculator. All right?